Welcome, young scholars. Before we delve into the intricate mechanics of our planet, allow me to welcome you to the study of geography.
At its heart, geography is not merely the memorization of maps or capitals. It is the scientific study of the Earth as the home of humanity.
It connects the physical world, the rocks, the air, the water, with the human experience. Today, we begin our journey by looking at our home from the outside in.
We will explore the external structure of the Earth. Imagine you are an astronaut approaching our planet from the vast darkness of space. What do you see? Not just a blue marble, but a complex breathing system. Let us examine its shape and its skin. Now, holding that image of the Earth in your mind, we must address a common misconception. While it appears round from a distance, the Earth is not a perfect sphere. It is not a flawless geometric ball like a marble. In academic terms, we describe the Earth's unique shape as a geoid. This term literally translates to Earth-shaped. Specifically, we call it an oblate spheroid. Picture a sphere that has been slightly squashed. It is flattened at the north and south poles, and it bulges outward at the equator. This bulging and flattening is the true form of our world, evidenced by precise satellite imagery and measurements from space. Having established the shape of our vessel, let us now examine the systems that operate on its surface. The external structure of the Earth is composed of 4 major interacting physical systems, which we call spheres. These are not separate entities, but rather woven together like the threads of a tapestry. We have the atmosphere, the layer of air we breathe, the hydrosphere, the water that sustains us, the biosphere, the web of life, and the lithosphere, the solid rocky ground beneath our feet. Let us look closer at the fluid layers first. First, cast your eyes upward to the atmosphere. This is the blanket of gases surrounding our planet, primarily composed of 78% nitrogen and 21% oxygen. It is our shield against solar radiation and the stage upon which our weather plays out. Below this lies the hydrosphere. This sphere encompasses all of the Earth's water, solid ice, liquid oceans, and gaseous vapor. It is vast, covering approximately 71% of the Earth's surface, with ocean basins plunging to average depth of nearly 5,000 meters. Together, air and water circulate energy and heat around the globe. While air and water provide the context for life, the biosphere is life itself. This sphere includes every living organism, from the microscopic bacteria in the soil to the great elephants of the savannah, all interacting within ecological communities. But where does this life stand? It stands upon the lithosphere. The lithosphere is the rigid outer shell of the Earth, comprising the crust and the brittle upper portion of the mantle. It is not an unbroken shell, however. It is cracked into massive tectonic plates that drift slowly over eons, creating the mountains and valleys we see today. Let us dig a little deeper into that solid crust. As geographers, we distinguish between 2 specific layers within the crust based on their chemical composition and density. The upper layer, which forms our continents, is called Sial. It is rich in silica and aluminum, hence the name SiAl. It is made largely of granite and is relatively light. Beneath this, and forming the floors of the oceans, is the Sima. Rich in silica, magnesium, and iron, the Sima is basaltic and much denser. Think of it this way. The lighter continental seal floats high like a block of pine wood, while the heavy oceanic simmer sinks low like a dense brick, creating the basins for our oceans. To summarize our lecture today, we have observed that our Earth is an oblate spheroid, not a perfect sphere.
We have identified the 4 interacting spheres: atmosphere, hydrosphere, biosphere, and lithosphere. And finally, we have analyzed the crest itself, distinguishing between the lighter granitic seal of the continents and the denser basaltic simmer of the ocean floors. For your study task, I would like you to sketch a diagram labeled "The Earth as an Oblate Spheroid and its External Spheres," ensuring you clearly mark the seal and simmer layers. Until next time, keep observing the world around you with a scholar's eye.